This is your friendly neighborhood physics teacher here, and we are going to go over the momentum-free responses on College Board. And so I just copied and pasted the questions in here. Some of the parts are a little bit hard to see because of my dark background. So if I need to redraw anything, I will, so y'all can maybe see it a little bit better. So for question 1, it says that this question is a long free response question. Show your work for each of the parts. Now, I'm just going to go over the parts that you will need for this version of AP Test. So we're not going to worry about any of the designing the labs or anything. We're just going to go purely over the open-ended short answer questions and deriving questions, because that's, they said, the type they're going to do on the AP test. So one thing, so you can't kind of see it, but I want to redraw. Come on. There we go. It's kind of funny when you have to get your digital ink to come down. So you do have this ramp, and you have a block here, and you have a block here. So this is block X, and this is block Y. That disappear. And block X starts sliding down, and then when block X collides with block Y, they become what's considered a two-block system. So they stick together. And so that's considered a two-block system. Your block Y is initially, come on, pen, it's initially at 0. But your block X is moving. And you can read that little descriptor, kind of tells you that there. So question 1, state the basic physics principles, laws, or equations that students could use to graphically determine the relationship between the release height of block X and the speed at which the two-block system travels after the blocks collide and stick together. So the word collide right there, the words colliding and sticking together, come on, pen, you know that you're going to be doing momentum. So your conservation of momentum should be one of the first things that pops into your head. And even if you want to write the equation, it sticks together, so it's an inelastic collision. So you can put max x of your v naught x plus y of v naught y would equal your mx plus my v final. So that's basically what they're looking for that first bit. Now, the second concept, you're dealing with height, you're dealing with movement, all of this, and these two concepts go hand to hand. If you're dealing with momentum, you are going to end up dealing with energy also. So conservation of energy should be your second principle that comes into play. And basically, the only type of energy you need to worry about is with block X, because block Y isn't moving until it actually collides. So you need to figure out your energy for your block X. So at the top, so if you're thinking about your total energy, your total energy is going to end up equaling your kinetic energy. Whoops, sorry, not, well, yes, but it'll be your potential energy, your gravitational potential energy, which will end up equaling your kinetic energy. So you could break that down and say your mxg, does it tell you delta y just for height, equaling your 1/2 mx v squared. So there you go. And this v is actually going to end up being your initial velocity in the x. That v is going to end up being your initial velocity in the x. Because you have a change, so right here as it's going down the ramp, your velocity is changing. So basically we're just trying to figure out like here what's going to be your box x here, so it can start being consistent when it hits. Because from the flat, which they probably should have moved your box down a little bit, but when it's just in the flat part, your velocity wouldn't be changing. So from here to where the curve ends, probably about there, your velocity is changing. It's actually increasing, right? Because gravity is making it go faster and faster. And then from here to here, as long as it doesn't hit something, your velocity, we're running out of room to write. Come on, pen. It's really weird when your digital pen doesn't work. You know, it makes sense when your real pen doesn't work because you're like, oh, it needs to work. But digital pen not working throws me off sometimes. So this is when your velocity would end up being constant. And the reason your velocity is constant is because it's not changing in the y anymore, just staying in the x direction. If you remember anything, things in the x direction stay constant unless it's acted upon an outside force. There's no outside force affecting it because it says that it's a frictionless surface, so we don't have to worry about friction in this case. Yep, there it is. So friction force between the boxes is considered negligible. So right here, that's saying right there, is telling us there's no forces in the x direction. So there we go. So those are two concepts we got to deal with. So now, the second part, it says derive an equation that relates to the initial released height of block X and the speed the speed versus the two-block system after the collapse. So the things that it has to be in terms of is mass X, mass Y, I don't know why it doubled when I copied it over, and the fundamental constants as appropriate. So we need so the only thing that needs to be in our equation is mass X, mass Y, and gravity. So those are the only things that can be in, well, that, and we're trying to see the relationship. So technically, we're relationship, so height. Come on, pen. So our height X can also be in the mix because we're trying to figure out the relationship between our height X and we're solving for our final velocity. So those are the things that can be in our equation. So question AI kind of sets us up. So we know what equations we're having to deal with right now. And honestly, it doesn't matter which equations you use first. You're kind of getting the same aspect here. So let's just use the momentum one because that was the first one. So basically what you're doing, and I'll break it down a little bit. So you have your momentum. Remember, P is momentum. I can write down a P. P of your initial of x plus your momentum initial of y has to equal your momentum of x plus your momentum of y. And of course, that's final. Put a little F for final if you want to. Break it down, that's where you get this. So your mass, because momentum is just mass times velocity, plus mass times velocity equals, but here they say it sticks together. So it sticks together. So your velocity is end up going to be the same. Go away, little thingy. So your velocity is going to end up being the same. So you can just do your mass of x plus mass of y equaling just your final velocity. So anytime that something says it sticks together, you can just use that. Now, up here, remember we stated that our initial velocity in the y is 0. So 0 times anything, 0 times anything goes to 0. Trying to get my pen to work again. There we go. So you get that your mass x, initial velocity x, equals mx plus my, your final. So that's as far as we can go on your momentum equation. And think about it. We can use pretty much all things. We can use that one. We can use all this. And we're looking for this. So the only thing we really need to get rid of is our initial velocity in the x. So we need to figure out what equation that we can solve for that. And that's when energy comes into play. So our energy would be our kinetic energy. Kinetic energy equals our gravitational potential energy. So that'd be our 1/2. I'm sorry, guys, my pen's not working. I don't know what's going on. This is getting kind of frustrating. 1/2 mx, your initial velocity squared, equals mx g, your delta y. Now remember, your delta y, it wants it in terms of hx. Your two masses can cancel out. So you're just left with 1/2 v naught squared, and it's really, your x. So that should be x equaling your g hx. And we're just trying to manipulate to get our initial by itself. So we have the 1/2. To get rid of 1/2, you're going to multiply both sides by 2. So you get your Vx naught squared equals G hx times 2. We need to get rid of the square root, or squared, so we square root. And we get that our Vx naught equals the square root. I'm just going to manipulate it so it looks a little bit prettier. 2GHX. Now this is when you can take this and plug it back into that mess there. So you get your mx square root of 2ghx equaling your mx plus my v final. And now you just do a little bit of manipulating, get your v final by itself because you're trying to compare the two. And you get that your v final of the whole entire system equals your mx times the square root of 2ghx over mx plus my. And I don't think we can simplify that any further. Nope. I mean, you can do some weird things with it, but I think that's as low as we can go. So there you go. There's your answer. So you have all of this mess to do all that. So we had to do our potential. We had to do our momentum, and we had to do our kinetic and potential. And remember, the reason your kinetic and potential is equal is because your potential at the top, because it's an even transfer, because there's no friction, so it's not losing energy anywhere, be the same as your kinetic at the bottom. So that's why you're able to set those two equal to each other. And you're just solving. There you go. So that is question 1 on the free response. So the video doesn't get too long. I'm going to stop there and then I'll start another video going over question 2. Actually, hold on. Question 2 is probably not that bad. Nope, I'll stop there. Have a good day. Bye.